Hello and welcome! Have you ever wondered why SQL Server does not use index you prepared for it? You prepared the perfect index for your query, for your where condition, equality, and SQL Server is ignoring it. Why? Today we will talk about this. My name is Vedran Kesagic. I'm a Microsoft Certified Master for SQL Server, and today's agenda is to explain a bit about index seek versus index scan, how we have two kinds of index seek, equality and range seek, and then we will go through a few examples from the beginner level to expert level, why index is not used, and we will deal with conversion, with functions. Not other reasons. There can be many reasons why index is not used, but we will tackle just one of them, which is adding a function around the column. So let's get started. But first, a bit of theory. What is index seek? And there are two kinds of index seek. Let's see. Index looks like this. It has a lot of pages with the data, key and included data. It has maybe millions of pages in the leaf level, and these pages above are index pages, which consist of one root page and many intermediate pages. It looks like a tree, like a hierarchy, and when you search for a row by index key, it first goes to the root page, reads one page, then goes to the next page where it is redirected by index key, and then finally comes to the last page and finds a row. That's only 3 page reads. Why we count these page reads? Because that's directly related to performance. If you read less pages, your query is faster, generally speaking. And that is called equality seek, because we found only one row. But there is something called range seek. Range seek. Imagine that you are searching for values between start and end value. That looks like this. It finds it similarly to equality, it starts from the root page to the intermediate page and leaf page, finds starting position. Let's say this is start position. Then it reads pages it needs, and then this is, let's say this is end row, end position, and this is a range seek. It's super efficient because, as you can see, we read only 2 more pages. And on each page, you can imagine it's about 100 rows. So we read maybe 200 or 300 rows with 1, 2, 3, 5 page reads. But if you are looking for only one row, you read only one row with 3 page reads. That means it's much more efficient to go with range seek. Why this range seek is so important? Because you remember, for one row we spent in equality we spent 3 reads, but for the range we spent only 5 reads here, only marginally higher number of pages, but we read a lot of rows because each page can contain hundreds of rows. So we read maybe 200-300 rows with just 2 extra pages. It is super efficient. So range seek is what we are after. If you can pack your results between 2 points of an index key densely, that's perfect index for us. I didn't mention a full scan. So full scan is when we start from here or here, from the top or bottom of the index, and then we read all the pages of the leaf level. All these pages, millions of pages. Full scan can take a really long time. That's millions of pages compared to only 5 pages for range seek. So that's range seek is we are after. We will talk about index seek operation, which we already talked, then explicit conversions, which are functions around the column, and they prevent index from being used, then we will talk about index hidden conversions, which are functions that are added invisibly behind the scenes to our column. And then we will talk about complex example and how to solve it. Complex example involves two columns in the condition in some comparison. And when you have two columns, that's really difficult to make it use index seek. Really difficult. So that's the last as expert level. And now the setup. We have one table here, which has only ID begint, which is identity, 1, 2, 3. Name is varchar, and due date is small date time. Small date time is very efficient because it takes only 4 bytes and consists hours and minutes. So it's ideal for meetings or something like that. Date plus hours and minutes. So insert 1,000,000 rows. Let's insert million rows. And the first 100 rows are 1, 2, 3, etc. Name is generated from number, that's why, but it's varchar, it's string. And due date, it's small date time. Some random. Let's index name and due date. ID is already indexed. And let's see what's the most efficient way to see the indexes on the table. Well, this is a handy procedure you can download for free and install. If you run it, it displays all info about that table. Columns and indexes. So we see all 3 columns are indexed here. And they have 1,000,000 rows and around 20 to 30 megabytes. By the way, you can download it for free here. This is the page. When you open it up, that's me 5 years ago. And you go here and click download here. You just install it. It's one procedure. Then you can configure it in here, tools, options, keyboard shortcuts, Ctrl F1, and you just write SPX details and nothing more. Then hit OK. In the next window you open, you can just select, for example, one table and press Ctrl F1. And voila, it's there. Or you can use it as a search. For example, just part of the name, Ctrl F1, and it finds everything that contains that string. Okay, let's move on. We will include logical reads statistics. We will enable statistics to see logical reads and actual execution plan. Now, let's see explicit function. If we search for all records of 1 month, sometimes people use this. Don't use this, by the way. This is a bad method to search for 1 month. Year of due date equals year of our date. And month of due date equals month of our date. That's really bad. You'll see why. Let's see. Execute 1,000 rows. What is the logical reads? We read 2,000 something pages. That's a lot, really a lot. And that's basically a full scan. If you look at this plan, here we can see that number of rows read is 1,000,000, but number of actual rows returned are 1,000 and something. That's because we have a predicate without word seek, and that means we read all 1,000,000 rows, checked them against this condition, and discarded one by one, and only 1,000 rows survived. That's basically this predicate. That's very inefficient, so we have here number of rows read 1,000,000, and actual number of rows that go into output is 1,000 and something. Let's see how to fix this, how to make this perform better. We must get rid of the function. And how to get rid of the function? We must have this column bare on one side of equality or inequality. And it is here. We have a bare column, no functions around it. We compare it with constant or a parameter. And here too is another condition, bare column, no functions around it, compared with a parameter or a constant. That should use the index. So let's see. Our limits are per month. That means 1st of February till 1st of March. And why we do that? Why we never, please don't ever use 23, 59, 99999, that's not good, because whatever nines you use, there is still a small piece of time that you can have a value between your nines and 0. So it's imprecise. You will have strange results if you use this 999 method. Don't use it. Use round numbers, round dates, and strict inequality on the right side, right? That's the trick. So let's see how that performs. You remember 2000 reads before. Now, let's see number of reads. 7, much better, right? Because, why? Index seek. Index seek is much better. Let's see. So you see seek predicates at the bottom, seek predicates, that word seek is important, and you see start and end. That means we have a range seek from start point till end point. That's what we are after. That's great. What if variable is declared in two parts, like year and month separately? Then we need to do the same, but we will assemble date from parts from year, month first, and then we will add 1 month to that. So you have year, month, and first day in month, and then you add 1 month to that, and strictly less than. That's the same thing. 7 reads. Index seek is here. This is just this part that looks complex, but it isn't. It's really super fast. It's just a calculation of the limits. You see, actual number of rows is 1, so upper branch is 1 row. That means lower branch is executed only once. So we have one index seek, which is from start to end. Then similar thing with if we have a date, let's say small date time, and we want all the dates from that month, which this date belongs. Then you just this is a formula to round to the first of that month, first day of that month. Then we add 1 month to that and strictly less. So you get the same thing, 7 reads and index seek, which is executed only once because this is actual number of rows is 1 in the upper branch, where it calculates the boundaries from start till end. And now implicit functions, that's the interesting one. So remember, we have search by name, but we do have index on the name. And this should work flawlessly, right? This should work flawlessly. This should use the index. Let's see. Execute. Number of reads, 3000. Wow, that's really a lot of reads. So let's see why. Index scan. Oh my God, it scanned entire table. Why? We do have index. Let's see. Control F1. On the name, we do have index with million rows. Why this index was not used? Well, let's see the execution plan. Once again, if you go to execution plan, look at this exclamation mark, yellow exclamation mark. It says warning, type conversion, convert implicit to nvarchar of column name. That means implicitly, behind the scenes, SQL added this function, like we wrote this. Oh, like we wrote this. That's the same. Why that happened? We now have function around our column, and because of that, index cannot be used. Index cannot be used if you have a function around your column. Why that happened? Because of different types. Let's see, this type of the column is varchar, and type of this parameter is nvarchar. Different types. One of these types will win, the other will be converted. All other types will be converted to that winning type. And implicit conversion is a function, and you get full scan. Super slow performance. There is a table with all the precedence of data types. And you can see that at the bottom is binary, var binary char, but nvarchar is higher than varchar. The one which is higher will win. That means if you have column which is varchar compared to a parameter which is n-varchar will win, and the column will be converted to n-varchar. Usually, wider type is higher. N-varchar is wider than varchar. Big int is wider than small int, etc. You can see the dates. Datetime is datetime 2 is quite high. Datetime offset is very high, and at the top is only XML and SQL variant. So how to solve this? We must make types equal and avoid implicit conversion. And that we will do by converting our parameter to the same data type as the column, which is varchar. So we will convert this to a varchar to have the same data type. Now we are comparing varchar to varchar, and data conversion should not occur. Let's test it. Yes, logical reads 3. That means index seek, which has seek predicates and equality. You see equality, there is no start end, it's just equality. That's 3 logical reads: root, intermediate page, and the leaf page. Only 3 pages. Very, very good. And now the tricky part. So far we compared the column with constant or parameter. But what if we have 2 columns? Is it possible to use index seek? No. Why not? Because index seek needs firm points to start and end that seek. And that points can be a constants or parameter values. If that is something variable, like some another column, that means there is no fixed point to start searching from. And SQL chooses full scan. And that's the case we will solve and see how to tackle with that. So first we must prepare our table. We'll add another column, which is offset from UTC in minutes. And then we will rename our date column to due date UTC, so we know it is in UTC time. Then we will give this new column offset, we will give it some value of the offset from UTC time, and then we will select. So you see that we have due date UTC, which is a date time, and we have some offset in minutes from UTC. This is exactly UTC, this is something else. So this is local time. Let's say this is local time offset from UTC. And we will create index which includes this offset, so it's appropriate for date searches. And we will drop the old index. Let's see how this looks, how indexes look. So you see we have this index with due date UTC, included is offset from UTC, 24 megabytes, million rows. Great. Not unique, but never mind. So we can search by this column due date. The task is to find the rows that are due today. But the trick is we must use local time. Now, that's the tricky part. We have conversion because to get the local time, we need to add the offset to due date UTC. And we are adding that offset. And let's say it equals to local time. I'm simplifying here, it could be a range between, but it's the same, the case is the same. This is just for the demo. So this, because this is a function, dateAdd is a function, this will perform bad. Let's try. Yes, almost 3000 logical reads. It is a table scan, index scan, so it scans all million rows and tests every row. Only 4 rows satisfy the condition, but we read million rows. That's bad. So let's try to somehow fix it. How can we do that? Let's try to move this offset to the other side of equality. If we move something, you remember from the math, when you move a variable to the other side of inequality or equality, then it changes the sign from plus to minus. So we have bare due date UTC, and on the other side we have minus that column. Now we got rid of the function here, but that function is compared not to a variable, but to something that depends on another column, that varies between each row. Each row may have another value. So this, how will this perform? The same, full scan. Full scan. Why is this full scan? Although this is bare column. Because SQL doesn't have a point to start scan. You know, that point is fuzzy. It depends on another column. We need to get rid of that dependency. And how to get rid of that dependency? That's the trick. That's the beauty of this lecture. So we will make this search wide enough so we can get rid of this other column. But we must have some knowledge about this other column. This other column is offset. And offsets in time zones can range from -14 to +14 hours. If we leave everything as is, and we just add a new condition that says daytime UTC is between today local -14 hours and today local +14 hours, we are sure that all local times are somewhere in between, because offset cannot be bigger than 14 hours up or down. And what that gave us, let's see, that gave us 4 logical reads. Wow, huh? That means we had index seek with seek predicates. You see seek predicates at the bottom, start, due date UTC bigger than something, that's a start point, and end point is due date UTC less than something. And that found 63 rows. You see up, 63 rows. These 63 rows were tested with predicate additional, with our old condition, which is dated, blah, blah, blah. And only 4 rows actually got out. This is super efficient because we read only four pages, and we tested only 63 rows, and we got 4 rows. This widening trick works only if we can make this range only a bit wider. If you wide it to the entire table, there is no use for that. Then you are doing a full scan. You need to get wider, but not too wide. Still be small in comparison to the entire table. Sometimes it's difficult to do. So why we didn't use datetime offset? We could, but this was a demo as an example for any such case. It could be a column in another table. It could be some other data type. It doesn't have to be a date. It can be something else. So the same principle applies. You just get wider to get index seek a range, and within that range you can test the rows with the predicate. That's super efficient. So in summary, column, in order to be searched with index seek, column must be bare, without any functions. Move away everything, plus, upper, lower, every function you move to the other side. So column is compared to the constant or parameter. Then data types must be the same in all conditions, if where condition, join conditions. Match data types. If you compare something with different data types, SQL will use that table of precedence, data type precedence, and he will implicitly convert weaker data type to a stronger data type. And that function, conversion function that is added behind the scenes, will prevent you from using the index, or you will get full scan and super slow performance. That's why you need to match the types. You explicitly convert the types you want, so you are in control. Don't rely on SQL. I mean, sometimes SQL can manage. SQL can get away. For example, with data type. SQL, when you convert to a date, sometimes SQL can avoid these conversion functions. It has some clever logic, but don't rely on that. Don't rely on that. Have that in control. You must match the same types and then you are safe. SQL is super smart, but it's better to be safe than sorry. If you have 2 plus columns in a criteria, then use widening to get rid of one of the columns. And that's something sometimes tricky, but it's possible. Thank you very much for your attention. I was enjoying in presenting it, and please visit my blog, and this is my email address, and see you in the next video. Bye, bye bye.